Universal law of gravitation. Universal law of gravitation, or we can say the Newton's universal law of gravitation. Newton universal law of gravitation says, let's say we have an object having a mass m and another object having a mass m. They are at a distance. So the distance from the center of mass, let's call this mass 1 and this mass 2. The center of mass 1 to center of mass 2 distance is r. Let's say r. So Newton law, universal law of gravitation says these two masses, they attract each other with a force. So this mass 1 will attract mass 2 towards itself, and mass 2 will attract mass 1 towards itself. So they will attract with a force, and that force is proportional to, F is the force between them, is proportional to the masses, the product of masses, mass 1 and mass 2. And this is, the force is inversely proportional to the square of the distance between them. So if I increase the masses, the force will increase, the product of mass will increase, and resulting the force will increase between these two masses. Let's say if I have huge mass here, mass 1, and another huge mass here, mass 2, they will attract each other with a greater force as compared to these two masses here on left hand side. And if I say let's say decrease the distance for mass 1 and mass 2, if I decrease the distance, the force will increase. So this is what this says. Then we can combine these two equations here, and we can write the equation for the universal law of gravitation. That is, so I wrote this small arrow on this force to represent it a vector, because the force is a vector quantity. So we'll write a g times m1 m2 divided by r squared. This is the Newton universal law of gravitational equation that says this is a g is a gravitational constant, gravitational constant, and its value is very small. It's in the order of 10 to the power minus 11. So we can express this force in terms of vectors. So if I just write a small cap here, this will be in a vector form. Cap, small r cap, represents the unity vector of r. If I want to write this in a vectorial form, then we need to go back and understand our concept of vectors, which is a unit vector we can define is a vector divided by its magnitude. So if I write this universal law of gravitation in vectorial form, this will be g times mass 1 mass 2 divided by r3. So magnitude, this will multiply here. Then here I have a vector here. So this is vectorial form of universal law of gravitation. Let's calculate the force between the two masses. Let's say we have 1 kg mass and another one is a 1 kg mass, and they are a distance apart 1 meter. So the force between them will be simply g times 1 divided by 1 square. This gives us force of which equals to g. So g, as we said, is in order of approximately 10 to the power minus 11. So our force will be very small amount of force between the two masses of 1 kg. So these two masses of 1 kg will attract with very small amount of force. It is almost negligible.